Okay, again, we're still hanging out with symbolic logic. So in our symbolic logic, we have a set of conditional statements that are related to the original sentence. So we refer to this first statement, so the if P, then Q, that's called our statement. Symbolically, we just use an arrow. Okay. Our converse is when we switch the P and Q positions. So if Q, then P, so symbolically, I guess I should be consistent, I seem to be doing capitals. The inverse is when we negate the original statement. So if not P, then not Q. So not P implies not Q. And our contrapositive is when we negate the converse. So if not Q, then not P. So negate the Q and negate the P. Okay, so given a sentence, we refer to the converse or the inverse of a particular statement based on the order in which we've negated or the order of which we've written the sentence out. Okay, so leaving the symbolic representation, let's talk about just in a sentence format how this might look. So in our original statement, so that's this first if-then part, we have the phrase, if I'm in San Francisco, then I'm in California. One very helpful idea is to label which sentence we consider to be P and which sentence we consider to be Q. And that helps us go back to our symbolic definitions as far as how to write out the physical sentence for each one. So then our converse, again, our definition of converse is Q then P. So if I am in California, then I am in San Francisco. Okay, that's our converse of the original statement. The inverse, okay, and that's not P to not Q. So if, and I just negate the P statement, if I am not in San Francisco, then I am not in California. And then our following is or the last one is the contrapositive. And that would be not Q to not P. So I negate the Q statement. So if I am not in California, then I am not in San Francisco. Interesting patterns emerge once we take a look at the truth values of the statement and a couple of the other things that we're going to look at, so inverse and contrapositives. And we come up with what are called logically equivalent statements. So let me set up the initial statement. So we got a P, and then we have a Q, and then we have P implies Q. Okay? Goes back to what we did earlier. So true, true, false, false, true, false, true, false. Okay, so where is the one false part located? And that's this, if the if statement is true and the conclusion is false, then it's false. Otherwise, it's true. Okay. Let's look at the negation. Okay, so this we consider to be the statement. Let's look at, let's actually go through the converse next. Okay, so converse, we're going to switch the order. So Q, P, so then Q implies P. Okay, so true, true, false, false, true, false, true, false. Right? Actually, let keep it consistent. Let me keep the order of what we have there. So true, false, true, false. Just so we can see in the same order. I don't try to confuse you too much. Okay, so where's this one false? Well, it's false anywhere where the initial statement, the if, is true and the conclusion is false. So that's false right there. Everything else is the same. Now, take a look at those truth values. They don't match. So a statement and its converse are not logically equivalent to each other. Okay, inverse. Inverse is not P and not Q. Okay, so let's go through the initial. So not P would be false, false, true, true. Not Q would be false, true, false, true. Okay, where's this one false? Well, it's only false in the one spot where I have a true in the if and a false in the conditional, so that part is false. Everything else is true. Okay, now look at that truth value versus the original statement. They don't match. But what do you notice about the converse and the inverse? Converse and inverses are logically equivalent. They have the same truth value. Okay, let's do contrapositive. All right, contrapositive is not Q to not P. All right, so not Q is false, true, false, true. Not P is false, false, true, true. Okay, where is this one false? It's false where the if part is true and the conclusion is false, so it's only false in that one spot. Everywhere else is true. Okay, what do you notice about the truth values? That matches the original statement. So the contrapositive is logically equivalent to our original statement every time. Okay, so I'm going to go to some applications of some of these logic statements. Let's start by what we define this to be. So if we have a true hypothesis and we have a conclusion that follows from the fact that it is true. Okay, so now we're talking about whether or not that hypothesis is true. Before we didn't care, we were just looking at what ifs. Now we're saying we know it's true and I have a conclusion that follows from it. That allows us to use the word valid. Okay, this is what's called valid reasoning. So anytime a conclusion follows unavoidably or follows from a true hypothesis. Okay, so let's look at an argument and see if we consider it to be a valid argument of some kind. Okay, we have two statements. In Washington, D.C., all lobbyists have influence. Now, you and I might not agree with that, but that's what we're going with, is that there's some truth to that. No one in Washington, D.C. over 6 feet tall has influence. Again, we are told these two hypotheses are true. Can I make this other conclusion? Is this other conclusion a consequence of those original two statements? All right, I'm going to go about doing this, illustrating this through Venn diagrams. And what I'm going to do is I'm going to say in Washington, D.C., all lobbyists have influence. So here's the influence bubble, and all the lobbyists live inside it. No one in Washington, D.C. over 6 feet tall has influence. Okay, so if you're over 6 feet tall, you don't live in the influence bubble. You live somewhere else. You have another bubble you live in. That's the 6 feet tall bubble. Say there's no one in the 6 feet tall bubble is in the influence bubble. Okay. And then the question is, persons over 6 feet tall are not lobbyists in Washington, D.C. Okay, so I have a person right there. We're going to put a little X. Now, I have a person who's living inside the 6 feet tall bubble, and I want to know, can I safely say that they are not lobbyists? Well, look at what we have in front of us. The only way you're in the influence bubble is if you are with the lobbyist, and since 6 feet and lobbyists don't live in the same bubble, then we can't say that they are the same person. So this, in fact, is true. It is a valid argument. Put my stamp of approval on it.